Okay, remember that anytime y is to an odd power or exponent, that's a function. Okay, so what we are looking at is, on page 65, you could take, in the examples, y equals x squared plus 2x minus 3, and we're going to rename it. That's functions. And you'll see that it's just a cursive F, sort of, and we just put the x there. And that's going to equal this equation. Now, remember that this is not multiplication. The way we distinguish that is that the f is in the cursive and you have the x. So this would be a function, and it's called f of x. Now, if you will go to page 66, and it tells you how to pronounce f of x, and it goes on. But what we're going to take a look at is now evaluating these functions. So if we have two functions, and they are the f of x is equal to that x squared plus 2x minus 3, and we have a second one now, and we call it g of x, and that's a different equation. You'll notice that it's 4x minus 2. So we want, in both cases, our x is going to equal 4. So x equals 4. We would say the f of 4 is equal to 4 squared plus 2 times 4 minus 3. And our g of 4 would be 4 times 4 minus 2. We are simply replacing 4 wherever the x are because they have told us x equals that 4. So you would go on and do the calculations. So you'd have 16 plus 8, then negative 3, and all of that would equal 21 on this side. And then you would do the same over here. It would equal 16 minus 2, which would equal then 14. When we say f of 4 equals 21, we are really saying that every time x is 4, the function f of 4 would be 21. The same thing would happen over here when we say when x is 4, g of 4, the function, would equal 14. We have our rules, and those are our equations. So let's practice. On page 67, at the top of 67, we have f of 2 is x squared plus 2x minus 3. The original function is this equation, and they have told us that f is 2. So we pull the f of x function equation, which is the x squared plus 2x minus 3, and we're going to put in 2 for every time we see the x. So that would be 2 squared plus 2 times 2 minus 3. So you would do your math. 4 plus 4 minus 3. That would be 8 minus 3, which would be 5. So our function f of 2 is equal to 5. Then we have the g of x, and that is our 4x minus 2. If you look across the f of 2, we have another f where they have substituted a negative 3. And that is now for our equation. So we are going to use the f function to solve this. Then you have, remember it's a -3, and this is what you want to keep in mind. It's that, so we're going to square the entire negative sign and the 3 sign. Then you put it into 2 times that -3 minus 3. Work to solve. This would be a +9. Remember to do the math. 3 times 3 is 2, and you have 2 negative signs. It makes it a positive. Do the math. 2 times 3 is 6. I have 1 negative, so that means my answer is negative. Now you have +9 and a -6 is a 3, and you have a 3 and -3. It's all equal to 0. So for the function f of -3, it is a 0. Looking at the bottom one, we are going to look at g of 5. Remember our original equation, the g of x, that's our original function. It's 4x -2. But they're telling us to substitute the 5 in. So we would say 4 times the 5, -2. We would have 20, a -2, that is 8. Get the idea now? It's just a pattern. So g of 0 would be 4 times 0, then a -2. So g of 0 would then equal a -2. Okay, so now just to make things a little more interesting, we're going to use our original f of x, and that's x squared plus 2x. We're using the same equation. Now, x doesn't always have to be a number. So just to kind of get your brain going, we're going to say, and g, I should do g of x as well, and that's our 4x minus 2. Okay, so in the middle of page 67, you notice now that g of x is an m. Well, it's the same process. All you have to do every time you see that x, you're going to put an m in. So 4m minus 2. And we're left with an expression that we cannot solve. So it's left that way because there's still a variable and we have no idea what that m is going to equate to. Same thing if you have a negative variable. You apply all the same rules that you have learned, and you would simply go, oh, I have a -r, and that whole thing is squared. Then I put in 2 and my -r and a -3. You still must do your math where you can. This would equate to r squared, because r times r is squared, and then the negative sign squared, it becomes a positive. This becomes a -2r because 2 times the -r gives me a -2r, and it's a -3. That's as far as we can go for that, and you would leave it just like that. Go ahead and do the next 2 equations. Pause the video and see if you are able to do them correctly. Okay, I will put them here. Okay, did you get it? It's not very difficult. It's just remembering all your math, and once you get the pattern down, you should be fine. Okay, on page 68, we have a few more that they want us to do, so we'll go ahead and do that. G of m equates to just substituting, oops, that should be an X, G, just replacing the M. So we would have 4M squared, and we're not doing anything with the constant, so that's in. Okay, here on this one, they tell us that f of negative 3r. You must take the entire thing inside there and replace it for each x. So, here we go. We have a negative 3r, and that's squared. Then we're adding 2 times a negative 3r, and leaving our constant at a 3. This would equate to 3 times 3 would be 9, and we have r squared. Remember, a negative times a negative is a positive. Then we're going to say 2 times our negative 3 gives me a negative 6, and then we bring in our r. Then we keep our constant, the negative 3. We cannot go any further, so that one is solved. Pause the video and do the next two. Even though they're expressions, remember to distribute and follow the same pattern. Combine your like terms. F of z plus 2. Just remember to follow the pattern. Z plus 2. That is squared. 2 times our z plus 2 and a negative 3. I'm going to draw a line so we don't get this confused. All right, remember that you, on the z plus 2 squared, this one right here, you square it, which means you're not going to say z squared plus 2 squared. You actually have to have 2 of that expression. So it becomes z plus 2 times z plus 2. A lot of students forget that. Here, it's a simple distribution, and I'm going to save that for after we get this right here done. So you FOIL it. Z times z is z squared. Z times positive 2 is a 2z. 2 times z is a positive 2z. 2 times 2 is 4. So here, the only thing we have to do is combine our like terms, and we end up with z squared plus 4z plus 4. Now we can bring in our distribution. So 2 times z, give me another 2z. 2 times 2 is a positive 4, and bring in our negative 3. Now you just simply combine all your like terms, which is the 4z, the 4z, and the 2z. 4 and 4. All right, so now let's combine our terms. I have a 4z and a 2z that gives me a 6z. And I also, don't forget your constants. And you have a 4 here in the center, a 4, and a negative 3. So you have 4 and 4 is 8, negative 3, and there's a positive 5. Okay, now the last part of 6 on page 68, the wording is a little confused, but what you're going to do is simply the math, and remember the rules to math. So we are given the function f of x equals the square root of x plus 3. And g of x is equal to 4 divided by x plus 3. Now, remember your math. What can you not have in the denominator? A 0. So you cannot have a 0. It's not equal. So whatever these x happens to be, it cannot be a certain thing that's going to give me a 0. What is your limitation for the square roots when it's uneven? You cannot have a negative number. It won't work. So let's go slow. F of 1, and I'm just simply going to plug it in. So my square root would be 1 plus 3. Do your math inside, the square root of 4, and remember your square root is just saying what are my doubles. I have a double of 2, so my function f of 1 is equal to 2. Let's try another. F of negative 4 is equal to the square root of negative 4 plus 3. Do the math inside. We end up with a negative 1. Remember, you cannot have a negative 1 inside a radical. So what you are saying is f of negative 4 is a non-real number. So negative 4 is not in the domain of f of x equals square root of x plus 3. So this would not be a solution. All right, let's take a look at our g of x's. We want to find out what g of 5, if that's a function. So we plug in our 5 where our x is. We have 4 is divided by 5 plus 3. 4 over 8, and that equals 1/2. So g of 5 is equal to 1/2, and that works. Take a look at g of negative 3. We have 4 is divided by a negative 3 and a positive 3. Well, 4, this turns out to be 0 over 0. It's undefined. So g of 3 does not exist because you cannot have a negative 3 in the solution for g of negative 3. Okay, so let's go on to page 69. Given the following functions, please identify their domain. If we are looking at the f of x equals the radical x plus 3, what cannot be inside a radical? A negative number. So you want to make sure that you highlight that in your book or star it, underline it, whatever you need to do to remember it. So whatever happens is that the equation to find out what x cannot be, we have x plus 3 has to be greater than or equal to 0. Which means, now when we go to solve this, we remember in beginning algebra, we solve inequalities just as if there was an equal sign. To get rid of the constant, we would just add its opposite and both sides. So x has to be greater than or equal to a negative 3. And then that would work because when you plug this back in and you have a negative 3 plus a positive 3, is that greater than or equal to 0? Yeah. Can we plot that? We can. And in the middle of page 69, you'll notice that there is a table. We are given what x is, then in the middle columns we have our function of x, and then we have to find our points. f of x is simply y. Remember that. F of x is telling us what our y coordinates are going to be. So in the table that you have, we are given x, then we have our function of x, and that equals our radical x plus 3. And then we need to find out, for every x that we have, we need to know what our y is, or our f of x. Yeah, my white table's not working. Okay, so the first one we've done, -3, we simply do the math inside. So -3 plus 3 equals 0. So every time x is a -3, our y is a 0. The next one, -2. Put it inside your equation. -2 and a positive 3 equals 1. Is 1 greater than or equal to 0? It is, so it works. -2 and a positive 1 is a coordinate we can use. If we have 1, put it inside. 1 plus 3. And remember, this is, you have to answer what that is, equals the radical 4, which is 2. We did this all in one step because 1 is 1 is 1, but it's still 1. That's why that works. Okay, so back here we have 1 and a 2, because we had to answer the radical. Now we're given a 5. Inside our radical, we have 5 plus 3 equals the radical 8. And now we can use our calculators to kind of get an approximation. And it's listed as a wavy equal sign, so it's close to 2.283. So every time x is a 5, we have 2.283 on my calculator. 0.283. And you can kind of give an approximation of where that is on the graph. We'll go over that in just a second. Let's take a look at our -4. Inside that radical, we have a -4 and a positive 3. So inside the radical, we have a -1. Remember, we cannot have a negative inside that radical, so there is no way to graph that. There's no solution for that. It's a non-existent number. -5. Inside the radical, we have a -5, and a positive 3 gives me a -2. Remember that it has to be greater than or equal to a -3. -6. Do the math inside. -6, positive 3 gives me a -3 inside the radical. So we have to say that these are not in the domain, not in the domain of this function. But the top ones are, and we can graph those. Okay, now that we have our points from our table, we can plot them. Our first one, x is a -3, and y is 0, so it's going to be right on our x-intercept line. Our next point is a -2, and our y is a 1. Then our next point is 1, positive, and y is 2. Then we have a 2.83 for 5, and you just have to be approximate. Connect your lines, and there's your graph. Remember, there is no domain over past that -3. Okay, there is one for you to do on page 70, and I will be attaching some PowerPoints for you, and the answer to that will be on the PowerPoint. I'm not going to draw it out here. But what I am going to do is go ahead and go to page 71 and do a couple of these practice for you so that you can get the idea. All right, so remember, you cannot have negatives inside even roots. That means the regular square root, or if you have an index of 4, 6, 8, and on and on. You cannot have zeros in the denominators, and you cannot have negatives or zeros inside logarithms. We're not really going to go into logarithms for intermediate algebra, but you may touch on them inside college algebra. So that's just kind of for the future. Here we go. F of x is equal to 7 divided by x plus 3. What can we not have inside our denominator? A 0. So what number would not work? X cannot be a negative 3. So it would be all the other numbers, but it cannot be a negative 3. Does that make sense? Please email me if you're having trouble with this concept. It's not entirely easy to grasp in the beginning, but at this point, we're just wanting to know what the domain is. And for the domain f of x, it can be any number, but not a negative 3. All right, so let's find out what the domain would be for g of x, because then we could graph all of the other ones. And on the graph, we would have every other graph, but not this negative 3. All right, so I have g of x equals x plus 3. So when we need to find out what x cannot be, we take what's inside our square root and we put it into our equation. X plus 3 has to be greater than or equal to 0. All right. Get rid of your constant by putting it on the other side, and so x has to be greater than or equal to a negative 3. And we just did that table, so that should be a little bit familiar. This is just showing you the equations and how we get to the point right away. All right, let's look at h of x equals the radical 2x minus 3. We are going to do the same step that we did over there, where you're going to set the 2x negative 3 has to be greater than or equal to 0. Add 3, add 3, 2x is greater than or equal to 3. X then has to be greater than or equal to 3 over 2. So that would be how we would say our domain is. It has to be all those numbers that are greater than or equal to 1.5. Take a look at the next one. I'm making a blank page for this one. J of x equals 2x squared negative 5x plus 7. All right. So we can think about that for just a minute. Well, when we take a look at this, we know that this is factorable, correct? And that there's no square radical, right? And no division problem to worry about. So in this one, it would be all real numbers. And how we write that is nice little fancy R, and that's just all real. So you could put all reals, you could put all real numbers, or you could put this R. Any one of those three is correct. Let's take a look at the K of x. It's 5x plus 11. Well, there are no radicals, and there's no division. So this would also be all reals. Okay, so you have some examples there, and section 2 will be due on Wednesday. We not sure if we're going to be in class or not, but stay tuned to your emails. If you have any troubles, you can't quite see something in the homework, you just need some extra help, or sometimes we get stuck on these because our brain goes into overworking and we sometimes think too much of these. If that happens to you, please just email me. I'll be checking the emails on and off all day long. Also, I am sending PowerPoints with those of you who like to follow us step by step instead of a visual. That will be included as well. Take care, stay warm, be safe.